Well, thank you very much to the organisers, OR60, for inviting us to speak at this event. We're independent systems thinkers, not affiliated to any organisation involved in the construction industry. What we're going to talk about today is Grenfell Tower. I think people, even from overseas, will have heard of the fire disaster in Grenfell Tower. And we want to take a look at fire risk in tall buildings, and in particular, where the height is a risk factor. Then we'll take a look at compliance with safety standards, how residents respond when confronted by a fire, and then finally make some remarks about our response as concerned citizens. Grenfell Tower, that's a plan representation of it, was part of the sort of building boom in London to replace the bombed out areas and sort of slum housing up to the 70s. So inspired by Le Corbusier, industrialised building took place, cheap, concrete-based, and it seemed to be very successful. In fact, 8% of people in London live in high-rises. And they are becoming popular again. More than 500 are in planning stage. What we want to look at here is Grenfell Tower, built in 1974 with 20 stories. And you can see it's a standard brutalist design. And 67 meters tall. In around 2015, 2016, it was renovated. As part of the renovation, 2 new floors were added, but they were added at the bottom, which led to some complications with indexing the floors, which turned out to be part of the problem that the fire brigade had in trying to rescue people. So Grenfell doesn't have any sprinkler system, and it only has one staircase for escape. The building since 2006, there would need to be sprinklers, and in other countries there would be a second staircase. The principle behind fire safety in tower blocks is compartmentation. So the idea is that you contain the fire for a crucial period during which people can escape. So fire doors typically, as part of the compartmentation, would allow people, in theory, 30 minutes. In practice, it didn't quite work out that way, much less. And so people can escape. And as part of that concept, there is a stay-put policy. This is very much worldwide. It applied to Grenfell Tower and was much criticised. The idea behind the stay-put policy is that you can't have everybody escaping down the stairwell at the same time, because that leads to a very dangerous situation in its own right. And furthermore, because in principle the fire is going to be compartmentalised, there is no central alarm. So people only, in some cases, find out about it when it's apparent to them through the smoke or through knocking and disturbance from other people. This may be contrasted with the type of escape policy that you get in offices and other buildings, which is a kind of escape as quickly as possible. I don't know how many people here know where you're supposed to escape from in this room here. Has anybody checked it out? Yeah. Right, and where do you go to? Outside, exactly. That's right, human psychology will say you go outside. Yeah, you go outside into fresh air. You're supposed to go to Physics Avenue, believe it or not. If we just step back a bit, when cladding first started to appear on the building, so 2009, Lakmal House, there was a faulty domestic appliance, and the building, that you can see that the fire spread through cladding, and 6 people died. The building did not have a valid fire risk assessment. The council hadn't carried it out, and the various other failings. the Southwark Council were fined for that. So that should have been an indicator of what was to come. In 2016 in West London, again there was another fire which spread through exterior cladding. It must be noted that cladding doesn't require any qualifications to install, whereas if you're installing a window, you need to be a competent person. For cladding, that's not necessary. The London Fire Brigade wrote to the councils, all the councils in London following this fire. The Lord Mayor, or the Mayor of London, said it was a terrible event. 50 people made homeless. But it doesn't seem that a great deal happened after that by the councils. There is an ongoing public inquiry, and the council's turn will come, and the building industry's turn will come to answer questions, and that should be unravelled at that point. But this brings us now up to 14th of June 2017. The fire at Grenfell, which is one of the worst that we've ever had in the country. It seems that almost everything that could have gone wrong did go wrong, and that our fire safety system in residential buildings is basically not working. It took just about 15 minutes for the fire to rush up to the top of the building. As you can see from this diagram, in fact, the water jets could only reach about the 10th floor. And it was everybody in the country is probably greatly saddened by the terrible event. But the question for us is that we test the hypothesis: is it the case that height is a risk factor? That is to say, the higher up you are in a building, is there a greater risk of death and injury? Now, as it happens, the data from Grenfell indicates that perhaps it's worthwhile taking a look at that as a hypothesis. Although in checking with building and fire safety experts, it seems to be that there isn't enough empirical evidence so far collected internationally to be able to claim that as a statement. But we will suggest that it is worthwhile taking a much closer look into this subject. What I'm going to do is give us kind of simplified overview of the risk factors associated with height. If we just start with the number of residents, clearly the taller the building, the more apartments there are, and the more residents there are. That means the more lodgers, the more subtenants, the more visitors, and so on. Furthermore, the more people that you've got, the greater the range of characteristics which are relevant to fire escape and fire safety. In the case of many tower blocks, there's a socio-economic dimension to it as well. It tends to be the less well-off people. Now, it's clearly the case that the taller the building, the longer it will take to come down a staircase. So staircase capacity and average speed of coming down the stairs is crucial. At the same time, inevitably, there's smoke coming up. There shouldn't be smoke coming up a fire escape because it should be protected from smoke. But as it happened, smoke came up through the fire escape, through the staircase. The rescue time is the time it takes for the fire brigade to run up the same set of stairs. So they're running up and down with casualties. A fire lift means that the fire brigade should be able to take control of the lift. That didn't happen in Grenfell. It was didn't conform. So running up and down is very, very energy consuming for the rescuers. It slows everything down as well. They need breathing apparatus, and so there's a limit to how high up they can run. And then when they rescue somebody, quite often they had to give their breathing apparatus to the people that are being rescued. So the fire brigade were in danger as well. And of course, another factor is that they were bringing hoses up, so the stairwell was full of hoses. So it was really very problematical to bring people down. A study conducted by the Buildings Research Establishment took a look at the relative fire risk for different building heights. And Grenfell's only, let's say, 20 floors, so you can see that even so, there is a significant, and that would be let's say the purple line, 30 minutes in principle, but in practice it was 0. But it's already, let's say, 200 or 300 times the level of risk relative to a 2-story building. And this is just looking at the factor of the time that you're given by the delay due to the fire resistance of the fire doors. So that's just one of the factors, but that didn't even work either. We now look at communications, and I would say, based upon the evidence given at the public inquiry so far from the fire brigade and from the BBC reports on their podcast, it's pretty clear that communications was crucial and was disastrous, because the number of calls coming in and out greatly overloaded the reception capability. There wasn't sufficient bandwidth, channel overload. We had a lot of delays and lack of feedback. So the red line indicates the fact that when fire brigade are in the building, they can't say, I've rescued somebody, or I've been to flat 76 and there was nobody there, or I saw a particular flat and there were people there. They can't communicate that back because their equipment is unable to communicate outside. Why is that? Because tower blocks have to have steel reinforced concrete. A steel framework gives you essentially a Faraday cage, so you cannot communicate with on the frequencies that they were dealing with. So we had really a very, what I would say, disorganized communication system whereby the call centers were unable to advise people to do anything other than to stay put, which is the official line. They didn't know what was going on. Now, essentially, the higher the building, the greater the logistic radius required for all the vehicles to come. So there's the fire vehicles. You had members of the public parking there, residents parking there. You had members of the family coming. You had a lot of people rubbernecking. So it was gridlock in West London at the time. So the fire brigade obviously found it difficult to get in themselves. You would have thought that water was available, but the water pressure wasn't sufficient. There were multiple pumps running. The dry riser inside the building didn't perform. The fire brigade themselves didn't have sufficient ladders, didn't go high enough. And so, as we see, the fire just burnt out the building. It wasn't possible to douse it in advance. Rather critically, if you are going to use water jets, you do need to be able to get close to the building, but that was again highly problematical because there wasn't a flat area, firm flat area on concrete, say, for the appliances. There was a lot of molten aluminium and other burning debris. There was a fear that the building was going to collapse. The basements were flooded, so they couldn't get access because of all the water they had managed to get out. And people jumped, people thrown out. It was a really gruesome situation. The police had to have shields to protect the firefighters as they came in and out with casualties. And looking at some of the other aspects of heights, the wind conditions meant that the fire and the smoke traveled very quickly up and around and down and through the building. And various forces of nature, in general, with higher buildings, more likely to get lightning, more subject to earthquakes. And in the future, we're looking at having to absorb a lot more heat in the taller buildings. So there are some factors which govern the greater risk associated with either having a higher building or living higher up in a tall building. So the question is then, can we say that height is the main risk factor? And the answer is yes, it is, but that's only for a particular building technology, and technology improves over time. So to give an example, Ronan Point was a disaster in '68 when it was just a concrete structure, and after an explosion, the whole thing collapsed. And building regulations were changed to protect against this. And indeed, Grenfell didn't fall down. Although, let's say the World Trade Center fell down, it wasn't actually built as securely as Grenfell was in that regard. As I mentioned, there's going to be over 500 tower blocks in London alone. It's incredible. This is just a view of the City of London as planned. You can see plenty of tower blocks in the background. And 90% of these new tower blocks are going to be residential. So there's some serious issues about how we're going to deal with those. And things are getting taller. Grenfell was just 22 stories. London's tallest, Europe's tallest, is 87 stories, the Shard. And Burj Khalifa in Dubai is 160 stories, and taller buildings have been built further. So the trend is up. But as a densification of living, is that the only direction it can take? There are other technological solutions, one of which is to adopt a different geometry. This is Singapore, the World Building of the Year 2015, and you can see it's stacked blocks which have got more than one escape route, and none of them in themselves you would describe as high-rise, they're mid-rise and stacked. So that's given an overview on the fire risk. Just a few observations now on compliance. As part of public inquiry, expert reports are written. Barbara Lane looked at Grenfell itself and found a culture of non-compliance. And that culture of non-compliance doesn't apply just to Grenfell. It will apply to all tower blocks that are controlled by local authorities. Judith Hackett was given the job of looking at fire safety in general and pointed out that we must look at buildings as a system. And Jose Torrero, another fire expert, spoke about the complexity of building systems and pointed out that it's necessary to move from a mode of compliance to a mode of competency. In other words, the people involved in designing and renovating buildings should be competent and understand more about the system as a whole rather than, if you like, the narrow domain that they are supposed to be expert at. Now, I'm obviously not going to have any time to go through the sort of system diagrams on these, but essentially, if we start with the fire burning and work backwards from that, we can look at all of the aspects which give rise to that fire being under control or not, as the case may be. And we think this is an appropriate way to examine the fire safety aspects. And just to give an idea of the complexity of it, if I sort of zoom out further, I think you begin to see, of course, that there's a huge amount of complexity involved in this. But what we're looking at is kind of color coding for the individual stakeholders and who would have different areas of responsibility. So that's compliance, which we can then look at in respect to a particular dimension. So, for example, looking at height versus compliance measures. Again, we can discuss this later on for those who are interested. Essentially, I think what we're looking at is moving from what we might describe as an authoritarian approach, where there are relationships between the landlord and the tenant on one hand, and where compliance has to do with conforming to a particular set of boxes that need to be ticked. And on the other hand, being more engaged with the community, with the residents, and taking more seriously their concerns and their observations. Because that affects not just compliance, but also affects their ability to escape effectively. So if we move on to the human response, then there are a huge number of factors which determine who escapes and why they escape. Putting in fire alarms may or may not work because we have learned indifference to alarms. Ditto sprinklers. If sprinklers go off at frequent intervals, then people will switch them off. A lot of the factors involved in the human response are themselves subject to, let's say, a considerable amount of discussion, debate, and depend upon psychology. So again, I don't have time to go through these in detail, but I think it is salutary to look at the evacuation profile of those who left the building. About half the people escaped in the first half an hour, and then there was a much slower rate. And you can see that the dotted line on the right-hand side marks the end of the stay put policy. But by that time, not very many people were escaping, so it was already too late by this period. So 72 died, and just under 300 were there at the beginning, according to the best evidence. Would abandoning a stay put policy earlier have made any difference? Well, the interesting thing is you can see a lot of people ignore the stay put policy anyway. And furthermore, if you get the evidence from the fire officers, they told people to get out as soon as possible as well. So it is a very mixed message that one's getting from the different sources, whether you're calling 999 control room or you're talking to some officials who are not involved. Anybody who was there was saying just get out. Again, we can look at specifically at the human response to fire threat. The crucial thing here is how people perceive the estimated time for the fire to reach me. And if they think it's going to be some long time away, then they tend not to react so quickly to that. And then how they react depends upon a whole bunch of other factors. Some people escape, others gather together. And what you get in all of these events, all fire events, disaster events, you get clustering. People cluster together for security, and they all die together as well in that case. To sum up, I think Grenfell demonstrates that the building industry needs to incorporate systems thinking, and public education in general is required, from school onwards. And I think that the operational research community can help promote systems thinking. And I think we should be looking to find ways to help residents to structure their decision making. Thank you very much.